Welcome to this beginner-friendly tutorial on C# game architecture. We'll explore the manager pattern, a powerful design approach that organizes game logic and systems effectively, crucial for building robust and scalable games. The audio manager centralizes the playback and management of all sound effects and background music. This ensures consistent audio behavior, allowing you to control volume levels and manage audio sources from a single, organized location. The manager pattern organizes complex game logic into distinct, manageable, and reusable components. This modular approach streamlines development, enhances efficiency, and allows different parts of your game to function harmoniously. Today, we'll focus on three essential managers forming the backbone of many C# games: the Game Manager, Audio Manager, and UI Manager. Each plays a vital role in organizing specific aspects of your game's core systems. First, let's delve into the Game Manager, the central hub for your game's overall state and flow. It acts as the brain, coordinating various systems and managing the core logic that defines your game experience. The Game Manager manages critical game data and states, such as player scores, lives, and the current game state like playing or game over. It acts as the single source of truth for these vital pieces of information, ensuring consistency. A common implementation for managers is the singleton pattern. This ensures only one instance of the manager exists throughout the game's lifecycle, providing a unique and globally accessible point of control for its specific responsibilities. This singleton approach prevents conflicts from multiple instances managing the same data. It provides a global access point, allowing any other script to easily interact with and retrieve information from the manager without complex referencing. Here's a C# code example demonstrating a basic game manager using the singleton pattern. Notice the public static game manager instance property for global access and the private constructor, preventing external instantiation and ensuring uniqueness. The awake method initializes the instance property when the game object loads. It also checks for and destroys duplicate game managers, ensuring only one persists and maintaining the singleton integrity throughout the game. With the singleton pattern, other scripts can easily access the game manager's public methods and properties. They do this simply by referencing game manager instance, followed by the desired method or property, making interaction straightforward and efficient. For example, a player script, when collecting an item, simply calls game manager instance.addScore to update the player's score. This delegates responsibility to the game manager, ensuring efficient and centralized score handling. Next, let's explore the Audio Manager, vital for creating an immersive game experience. Sound design plays a massive role, and a dedicated audio manager ensures this crucial aspect is handled professionally and consistently throughout your game. The Audio Manager centralizes the playback and management of all sound effects and background music. This ensures consistent audio behavior, allowing you to control volume levels and manage audio sources from a single, organized location. This manager handles playing one-shot sound effects, seamlessly looping background music for different game areas, and controlling overall game volume. It ensures a dynamic and responsive audio environment for players. Here's a C# example demonstrating a basic audio manager implementation. This class typically includes essential functions like play sound for short audio cues and play music for continuous background tracks, providing a clear interface for all audio interactions. It typically uses audio source components to play sounds and stores references to various audio clip assets. These are the actual sound files, allowing the audio manager to easily access and play them on demand, managing your game's audio library. The play sound method is designed for transient audio events. It takes an audio clip and plays it once, without looping. This is perfect for short, impactful sound effects like button clicks, weapon fire, or explosions, providing immediate audio feedback. In contrast, the play music method is tailored for handling longer, looping background tracks. It ensures your game's musical themes play continuously and can facilitate smooth transitions between different pieces of music, enhancing the atmosphere. Beyond basic playback, a robust audio manager can implement sophisticated volume control and elegant fading effects. These features are crucial for a polished audio experience, allowing you to dynamically adjust sound levels, or smoothly fade audio in and out during game events. For instance, when a player enters a new area, the audio manager can smoothly fade out the current background music, creating a seamless transition. It then gently fades in a new, appropriate track for the new environment, enhancing immersion. Finally, let's examine the UI manager, responsible for managing all user interface elements within your game. The UI is the primary way players interact and receive information, making its efficient management paramount for a good user experience. The UI manager centralizes the display, updating, and management of all UI components, such as player scores, health bars, and pause menus. Consolidating these responsibilities ensures all visual feedback to the player is handled consistently and efficiently. This centralized approach ensures your user interface remains consistent and highly responsive to game state changes. Whether health decreases or an objective appears, the UI manager guarantees the visual representation is always accurate and up-to-date. Here's a C# example illustrating a basic UI manager implementation. This class includes methods to update dynamic UI elements, like updates core text, and functions to control the visibility of entire UI panels, such as show game over panel based on game events. To interact with visual elements, the UI manager typically holds direct references to Unity UI components. These include text components for dynamic text, image components for health bars, or game object panels representing menus, allowing direct manipulation. The updates core text method is an essential function. It takes an integer score and efficiently updates the text property of the corresponding UI text element on the screen, ensuring players always see their accurate score in real time. Methods like show game over panel are crucial for managing the visibility of larger UI structures. These functions activate or deactivate entire UI panels, often GameObject-S, based on specific game events, providing dynamic UI control. For the UI to reflect the game's current state, the UI manager often needs data from other systems. It achieves this by subscribing to events published by the game manager or directly querying it for the latest data, maintaining clear communication. For example, when the game manager updates the player's score, it notifies the UI manager. The UI manager then receives this information and updates the score display on the screen, demonstrating a clean separation of responsibilities and efficient data flow. This clears separation of concerns, where the UI manager handles presentation and the game manager handles game logic, is fundamental. It keeps UI logic clean, modular, and decoupled from core game mechanics, making both systems easier to develop and maintain. Now, let's recap the roles of each manager and understand how, when combined, they contribute to building a robust, organized, and highly maintainable game architecture. This holistic view highlights the power of the manager pattern. The game manager acts as the primary orchestrator of the overall game flow. It manages critical game states, such as player scores, lives, and progression through levels, ensuring a consistent and controlled experience. Essentially, the game manager functions as the central authority for all game-specific data and events. Any other system needing core game information will query the game manager, making it the single, reliable source of truth. The audio manager provides a comprehensive and unified system for handling all sound effects and background music. It ensures every audio cue is managed consistently and professionally, enhancing the player's auditory experience. Its core responsibilities include consistent audio playback, granular volume control for different audio types, and smooth transitions between music tracks. This level of control is vital for creating an immersive and polished sound environment. The UI manager handles all visual user interface elements, bridging your game's logic and what the player sees. This includes dynamically displaying scores, health bars, and managing complex in-game menus, ensuring a clear visual presentation. Crucially, the UI manager ensures the user interface is always up-to-date and highly responsive to game events. When something significant happens, the UI manager reflects that change visually and immediately, providing instant feedback. Together, these three managers, game manager, audio manager, and UI manager, form a powerful trio. They create a well-structured, organized, and scalable architecture for your C# game, ensuring specialized, efficient systems work in harmony. This modular approach, with each manager having distinct responsibility, makes it easier to add new features without disrupting existing code. You can often extend a specific manager without affecting other parts of the system. Maintenance becomes simpler and less error-prone because each manager has a clear, defined responsibility. When a bug arises or a change is needed, you know exactly which manager to investigate, reducing debugging time and making your codebase manageable. Collaboration among team members is greatly improved with this structured approach. Different developers can work on separate managers concurrently, leading to more efficient teamwork and faster development cycles for your game. While the singleton pattern offers convenience, be aware of its drawbacks. These include tight coupling, where components become overly dependent, and difficulty in unit testing, as mocking its behavior can be challenging. Use it judiciously. For larger, more complex projects, consider alternatives like dependency injection for greater flexibility and testability. This allows providing dependencies from an external source, promoting looser coupling and making your code easier to test. Always strive for clear, readable code with meaningful comments and consistent naming conventions. Well-documented code is invaluable for future understanding for your teammates and for anyone else who might need to modify your project. This beginner-friendly approach to game architecture, focusing on the manager pattern, lays a strong foundation for your C# game development journey. Applying these principles early on sets you up for success in building more complex games. By implementing these manager patterns, you're building games that are not only fun but also robust, stable, and easy to expand upon. This foresight in design saves countless hours when adding new features or content. To solidify your understanding, actively practice these concepts by creating your own simple game projects. Start small, perhaps with a basic score system, and gradually build complexity, applying what you've learned in a hands-on environment. Experiment with different ways to integrate these managers into your projects. Observe how they improve your workflow, make your code cleaner, and simplify adding new features or debugging issues. Each experiment deepens your practical understanding. The journey of becoming a proficient game developer is continuous, involving constant learning, adaptation, and practical application of new knowledge. Embrace challenges, seek new patterns, and always strive to improve your architectural skills. Thank you for joining us in this tutorial on C# game architecture and the manager pattern. We hope you found the explanations clear and the examples helpful in understanding these fundamental concepts for building better games. We sincerely hope this guide provides you with the foundational knowledge and practical insights to build better, more organized, and ultimately more successful games. Keep coding, keep learning, and enjoy game development.